So what we're going to do now is walk through a bunch of different examples that show off some of the functional programming features that are in Java. And this is important because I'm assuming you know object-oriented features of Java, things like what's a method and what's a class and what's public, private, protected access control specifiers. But you may be less familiar with some of the functional programming features in Java. For those of you who've taken the Foundations of Software Engineering or Fundamentals of Software Engineering course, we cover Java functional programming in the beginning. For those of you who haven't taken that, there's a set of videos I mentioned, which you can find in item 12 in my FAQ. And that's a good way to learn this. So what I thought I'd do is walk through a bunch of examples just to illustrate functional programming and compare and contrast it with other more traditional styles of programming. And this particular example is a good starting point. So this is example EX0. And you can see we have an array of strings, people's names, and we're going to go ahead and call a zap7 method, which is going to use Java 7 features or earlier versions than modern Java features. And then we're also going to have the same zap method that uses modern Java features. And just for fun, you can see here that we're going to take that name array and we're going to convert it into a list by using the list of factory method. And that will convert the array of strings into a list of strings, which we then are going to zap. And then after we zap these things, we come down and make sure that we zap them appropriately. We're going to take out the name Robert from this, and then we'll make sure it worked. So this is kind of the classic way of doing things in old school Java. So if you're using old school Java, which is sort of Java 7 and earlier, then this is what it looks like. So we pass in a list of strings. We have a string to omit. We create ourselves a new array list, which we treat as a list. Good thing to remember about Java, whenever you have an extended class, a subclass, and there's an interface or a superclass, it's usually a good idea to try to use the type of the superclass or the interface instead of the subclass. So you'll notice how we use list of string here, even though we allocate an array list there. And so the reason, why do we do that? The reason for doing that is that way we could come along and we could change this to, say, linked list, and the rest of the code wouldn't change. Whereas if we were to put array list here, then we're stuck with an array list. That just gives us a bit more degrees of freedom. And you also probably know in real life, you'd use some kind of a factory method rather than saying new array list, but that's more complicated than we need at this point. So once we've got ourselves the result list, we're going to go ahead and iterate through all the lines. And for each line we have here, we're going to go ahead and check to see whether the line, the line that we've got is equal to the one we're trying to omit. If they're equal, then we skip over that line because we're omitting it from the result. If they're not equal, which is what it says, if it's not equal, then we add the line to the results list. And when we're done, we return the list. Now, hopefully this looks very familiar to you because this is the way you write that kind of code in classic Java. The problem, of course, with this is it's very tightly coupled to a particular way of doing things. In particular, if you want to make this run concurrently, you're going to have a lot of work on your hands trying to modify this code to make it run in parallel. And that's not a good thing. In fact, there's even a name for this way of doing stuff. It's called the accumulator anti-pattern. And if you Google accumulator anti-pattern, you'll find there's an article written by Brian Getz, who's one of the Java architects who talks about the accumulator anti-pattern. So while this is very time-honored way of doing things, not really the right way to go. A better way to do things is to use modern Java features, which is what we're doing here. And so what we're going to do in this case is we're going to pass in the same parameters. We return the same result, but the implementation is entirely different. It uses a declarative approach instead of an imperative approach, which is what we did before with the Java 7 stuff. So the first thing we're going to do is we're going to convert the list to a stream using a factory method called stream, which is something that's defined on collections like lists or linked lists, array lists, sets, and so on. And then we're going to use a fluent chain of intermediate and terminal operations to do transformations on that stream. So the first thing we're going to do is we're going to remove any methods that match or remove any strings that match omit. So if something in our stream matches omit, we're going to ignore it. So what we're going to do is we're going to make anything that is not equal to omit go through, and anything that equals omit will not go through. So that's what filter does. It only lets things through that match the predicate. And then we're going to use a terminal operation called collect in order to be able to coalesce all the elements of the stream that pass through that filter, convert them into a list, which happens to be implemented as an array list using this particular toList factory method. And then that gets returned as the result of the Zap modern method. And you may or may not understand what this code does, depending on how much you know about streams or functional programming, but it's got a bunch of virtues that we didn't have with the previous version. The most obvious of which is, if we want to make this run in parallel, we just change stream to parallel stream, and boom, all of a sudden everything runs in parallel. Now, as to whether that actually makes things run any faster or not is another issue altogether, and we'll talk more about that as the course goes along. And if you watch some of the videos that we do when we get to the parallel streams section of the course, which I think is probably around week 6 or 7 maybe, it will go into great detail about when to apply parallel streams, when not to apply parallel streams. If you only have a small number of lines, it's probably overkill, or a list with a small number of elements. If you have a lot of elements, then it makes more sense to use parallel processing. So that's probably the most obvious benefit of using the functional approach. The other obvious benefit is that we are saying what we want done, not how to do it. And so that's really the main way that this code here differs from the code up here. This code is imperative and says what to do. It says how to do it. This code down here is declarative and just says what you want to have done. So it's declarative. So those are the main benefits.